In this lesson, we will learn how to find the inverse of logarithmic functions. In general, there are two steps to finding the inverse of a function. Step one is that you switch x and y. And then step two is you solve for y. That's a terrible V. OCD! Switch x and y and solve for y. That's how you find the inverse of any function. Now, of course, the devil is in the details, or as my wife would say, God is in the details, which is a nicer way of saying it. The y equals log base 3 of x plus 2. Okay, that is what we really have. This f of x is just like a y. So we need to switch x and y and solve for y. If we switch x and y, this becomes x equals log base 3 of y plus 2. So that's great. The question is now, how do we solve for y? Well, with this y inside of a log function like this, the only way to get it out would be to rewrite this in exponent form. All right, when you're changing forms, always start with the base. See, the base is 3. So in exponent form, I will just bring that base 3 down. Now, the x and the y plus 2 are going to wind up sort of switching places. Okay, but this x over here is going to be an exponent, and then the y plus 2 comes over here. So I've got y plus 2. Now we're trying to solve for y. You can see that we are one step closer to having y by itself. But now we just have to subtract 2 from both sides. So that would give us y equals 3 to the x power minus 2. Okay? Now we started off with f of x. So we have to go back to that and write f of x equals 3 to the x power minus 2, except for one thing. This is now the inverse function. We can't have f of x and f be two different things. All right, this is the inverse. So what we do is we put a little minus 1 on this one. And it's read f inverse is equal to 3 to the x power minus 2. And this is what you will put for your final answer. By the way, if you have a pencil in your hand right now, put it down. Throw it across the room if you have to. All right, stop your cheating. Sure, watch the video, learn how to do it. But then you want to leave yourself a blank problem to go back and do the problem yourself. All right, that's how you'll see if you really know it or not. Yeah, so like we say, this is really like having y equals log base 4 of x minus 7. So we're going to switch x and y. So this will become x equals log base 4 of y minus 7. Now, as we solve for y, the first thing you want to do is add 7 to both sides, like this. So that's going to give me x plus 7 is equal to log base 4 of y. So you know at some point we're going to wind up changing forms, rewriting in exponent form. But you always want your log expression by itself before you change forms. So you don't want to do it while there's this minus 7 over here. So that's why we did that. Now that we have the log expression by itself, we can write this in exponent form. Start with the base. The base is 4, so I'll drop down a big old 4. Now the x plus 7 and the y are going to sort of switch places. So I'm just going to have y equals. Now the x plus 7, when it comes over here, it's going to be an exponent. And look, y is already by itself, so that's it. Now we can just put the c back in here. So we'll have c, but don't forget the little negative 1, because this is now c inverse equals 4 to the x plus 7 power. This is the inverse function. All right, number 3. we have to get the log function by itself, the log expression. Now this is y equals, so switching x and y, this will become x equals negative 2 log base 1/2 of y. Before we change forms, we need to get the log expression by itself. So that means we need to divide both sides by negative 2 to get rid of that. So these cancel out. Okay, so that means I have x over negative 2, which is the same thing as negative x over 2, is equal to the log base 1/2 of y. So let's go ahead and rewrite this in exponent form, starting with the base. Alright, so this will be 1/2. Alright, now the y is going to come over here, and the negative x over 2 is going to come over here. So the y over here makes it with y equals. Now this will be the exponent, so it's like negative x over 2. Okay. And this would be the same thing. Well, first of all, getting the d back in there. So this will be d inverse equals 1/2 to the negative x over 2 power. But you really don't want to leave it with a negative exponent. Well, put it in a way that you will understand. You will not get full credit if you leave it with a negative exponent. Okay, maybe half credit so far. What did I tell you to do when you have a fraction and a negative exponent? Hopefully you said reciprocal. So this would be the same thing as 2 to the positive x over 2 power. Now isn't that simpler? So you definitely want to do that. So this is the best answer for number 3. Alright, in number 4, once again, this is like y equals. So as I switch x and y, which is always the first step of finding the inverse, this will become x equals log of y minus 5 plus 4. Now keep in the back of your mind that this is base 10. We're going to need that later. But before we rewrite the other form, we need to get the log expression by itself, which just means that we need to get rid of the minus 4. So we will have x minus 4 equals the log of y minus 5. Now here's where you need to remember that this is an invisible base 10, because we're going to need that 10 as we write this in exponent form, starting with the base. So we'll bring down the base 10, and now the x minus 4 and the y minus 5 will sort of switch places. So I will end up with y minus 5 out front, and then this will be the exponent of the 10. So this will be 10 to the x minus 4 power. So we're trying to get y by itself. It's almost by itself except for the minus 5. So we just need to do a plus 5 on both sides to cancel those out. So this is going to be the final answer, but we'll go ahead and put the g back in. So we'll have g inverse equals 10 to the x minus 4 power plus 5. And this is the inverse function for function g. Alright, so that was number 4. Let's take a look at number 5. Okay, so we have our y right here. So this will become x equals 2 log base 6 of y plus 4 minus 1. So first we need to get the log expression by itself. So we need to add 1 and divide by 2. Let's start with the adding 1 to both sides. So this will give me x plus 1 equals 2 times the log base 6 of y plus 4. Now we need to get rid of this 2. You can do that by just dividing both sides by 2. So that'll give me x plus 1 over 2 is equal to log base 6 of y plus 4. Now that we have the log expression by itself, we can go ahead and rewrite in exponent form. Starting with the base, it gives us 6. Now this y plus 4 is going to come over there and become y plus 4 equals, and this x plus 1 over 2 is going to come over here and become the exponent. So I will have x plus 1 over 2 way up high because it's the exponent. And then we will subtract 4 from both sides. So this is about to be the final answer with y by itself. So let's just look back and see, alright, this is function h. So I will write h inverse equals 6 to the x plus 1 over 2 power minus 4. Alright, that was number 5. Here comes number 6. Ln, natural log. Please remember that this is an invisible base e. We will need that fact later. So since this is really like having y equals, as I switch x and y, I will have x equals natural log 3y minus 1 plus 2. Okay, before we go changing the form, we need to get the log part by itself. So let's subtract 2 from both sides. So this will give us x minus 2 equals natural log 3y minus 1. Now here's where we need to remember that natural log of something means log base e. So I'm just writing that down for a moment to remind me that when I do the exponent form, I start by bringing down this base e that was invisible. Now these two parts basically change sides. So I'm going to have 3y minus 1 and then e to the x minus 2 power. Alright, but we need to get y by itself. So to get y by itself, let's add 1 to both sides. So that'll give us 3y is equal to e to the x minus 2 power plus 1. And finally, we need to divide both sides by 3 to really get y by itself. Alright, and this is the final answer. This was a k function, so I'm going to go ahead and put k back in it and write k inverse equals e to the x minus 2 power plus 1 all over 3. Alright, that was number 6. Here's number 7. Okay, this one's a little different. All the other problems we've done so far in this lesson have been log functions. This one's an exponent function, so you can bet that we're going to wind up switching to log form. Alright, so first of all, we have y equals 2 to the x plus 1 power. We're going to switch the x and y and solve for y. So switching the x and y gives us x equals 2 to the y plus 1 power. Now, this exponent part is already by itself. So we can go ahead and rewrite this in log form. Always start with the base. Since the base is 2, that means I will start by writing log base 2. Now these two parts are going to switch places. So out here I'm going to have my y plus 1, And here I'll have log base 2 of x. Alright, we need to get y by itself, so just subtract 1 from both sides. So this is about to be the final answer, so I'm going to go ahead and put the q back in and just call it q inverse equals log base 2 of x minus 1. No parentheses here. So this is the final answer for number 7. Alright, again, if you have a pencil in your hand, please put it away. Watch me do it so you can learn how, but go back and do these problems yourself, please. It's the only way to learn. So this starts off y equals. So switching the x and y, I will have x equals 2 to the y power minus 5. Now, before I can write this in log form, I need the exponent part to be by itself. So I am going to add 5 to both sides like this. And that will give me x plus 5 equals 2 to the y power. Now, if I rewrite this in log form, because I'm trying to get y by itself, start with the base. The base is 2, so I will have log base 2. Now the x plus 5 and the y are going to switch places. So I'll have y equals, and then log base 2 of x plus 5. Now this time I need to put this in parentheses because the x plus 5 and the y, it's this entire x plus 5 that I'm taking the log of, not just x. So alright, so that's key. I fear a lot of people would leave off the parentheses, but that would be wrong. So that's your answer to number 8, with parentheses, please. Okay, how about number 9? Well, this is like if I switch the x and the y, I'll have x equals 1/2 5 to the y power. Before I write in log form, I need to get rid of this 1/2. So the easiest way to do that is to multiply both sides by 2. That way these cancel out and they're gone. They make 1. So that means now I have 2x equals 5 to the y power. Now it's time to go ahead and rewrite this in log form. So this would be log base 5 of 2x, okay, equals y. So this is what we would have in log form. And that's it. Y is already by itself. I'll just put the s back in. So this will be s inverse equals log base 5 of 2x. So that is number 9. So this is like having a y. So we will switch x and y. So that will be x equals 3 times 4 to the y minus 3 power. Now before we write this in log form, we need to get rid of this 3. Alright, the base and power have to be alone. So let's divide both sides by 3 first. Make that 3 go away. That gives us x over 3 is equal to 4 to the y minus 3 power. Now that the base and power are alone, we can write it in log form. Starting with the base. So we will write log base 4, and then these two guys are going to basically switch places. Okay. So I'm going to have my y minus 3 over here and my x over 3 right here. So y is almost by itself. We just need to add 3 to both sides like so. Now this is about to be the final answer, so I'm going to go ahead and put the t back into it, and being careful to put t inverse with a little minus 1. So t inverse equals, and here we go, log base 4 of x over 3 plus 3. All right, no parentheses here. So that's number 10. All right, number 11. I see we got that base e. I feel a natural log coming. So watch out, watch out. This is y equals. So switching the x and the y gives me x equals 3 times e to the y minus 1 power plus 9. Before we can write log form, we have to get the base and power by itself. So we have to get rid of the 9 and the 3, starting with the 9. So let's subtract 9 from both sides. That's going to give us x minus 9 equals 3 times e to the y minus 1 power. Now we have to get rid of the 3. So let's divide both sides by 3. So that's x minus 9 over 3 equals e to the y minus 1 power. Now that we have the base and the power by itself, we can rewrite this in log form, starting with the base. So at first, I write log base e, and then I switch places. Okay, so this would be y minus 1 is over here, and this mess is going to be right here, so it'll be x minus 9 over 3. But then I realize we don't write log base e, that's natural log. So I'm going to go ahead and add 1 to both sides, but when I write the final answer, putting the, putting the b back in, all right, so I'm going to have b inverse equals, I am not going to write log base e. Instead, I will write natural log. All right, the base e is now understood. So natural log x minus 9 over 3 plus 1. Wait, Mr. Burden, are you going to take off points if we just leave it log base e? Yes. This is an important little detail that I need you to learn from my class, that log base e is natural log. So show me that you learned it, or suffer the consequences. All right, number 12. Once again, switching the x and y. If you have a pencil in your hand, put it down. 3y. Watch me do it, but go back and do it yourself. Put your pencil down if you have a pencil in your hand right now. So we switched x and y. Now we got to solve for y. So let's add 1 to both sides. So that would give me x plus 1 equals 10 to the 3y power. Well, once I have the base and the power, I can rewrite it in the other form, starting with the base. So this would be log base 10, whoops, I almost put 3y. The x plus 1 and the 3y are going to switch places. Now this is where I need parentheses, because this x plus 1 over here, I'm not just like adding 1 to both sides. Excuse me. This x minus 1 is a package. So it's going to come over here. But when we have the log of x plus 1, the x plus 1 has to be in parentheses. And I'll have the 3y like this. Now once again, base 10 is something that we don't write down. Log base 10. The 10 is understood, so when I do the next step, I'm going to get rid of that 10 and just put log. We're almost done, but we have to get that y by itself. So we would now divide both sides by 3 like so. And this is about to be the final answer. So I'm going to switch back to D mode. So let's put D inverse equals, all right, now I'm getting rid of the 10, it's understood, so log x plus 1 all over 3. All right, if for some reason you wanted to put 1/3 log x plus 1, that means exactly the same thing. All right, was that it on this page? All right, so that was it for the front page, and I think that was it for the new material. Okay, the rest of this is review material. Keeping in mind that we do have a test coming up, so let's remember our review material. Okay, put your pencil down, no pencils. We are supposed to expand these next few problems. When you look at this, I need you to see this in parts. So we've got the 35, and then we've got the x to the 4th power. Okay, that has to be split apart. All right, we're talking about the product property here. The log of something times something equals the log of the first thing plus the log of the second thing. So this is the log of AC. So we're going to rewrite this as the log of 35 plus the log of x to the 4th power, right? That's like my A and my C, and this is my A and my C. You got to split those up. But then there's one more step we have to do based on the power property. When you have an exponent like that, in expanded form, you put it in the front. Okay, so this 4th power is going to jump over here. So we will have log base 3 of 35 plus 4 log base 3 of x. So there's number 13. Similarly, number 14. All right, the numerator and denominator. In fact, forget about that. Here's what I want you to understand. Please listen carefully. There are 4 different things here. We've got the 4 and the y, and we've got the x and the 5. I want you to see this as 4 different things. Now, we're going to use a combination of the product property and the quotient property because we have things being multiplied and things dividing. But bottom line is this: are you listening? Everything in the numerator is going to be a positive term, and everything in the denominator is going to be a negative term. All right? So that means we're going to have the natural log of 4. Okay, that's the first thing. It's positive. It's in the numerator. Plus natural log of x. Also positive. It came from the numerator. Now I still have the 5 and the y. These will both be negative. So minus natural log of 5, and then minus natural log y. And there are no exponents, so this is done. So again, when you see something like this, don't just see 2 things. Some kids are doing this: natural log 4x minus natural log 5y. That's not wrong, but it's not finished. If you still have a product here, then these have to be split up. So this has to go, I'm messing up here. So this has to go natural log 4 plus natural log x, so you have to split that up. And then this also has to be split up, natural log 5 plus natural log y. But then you have to remember to use parentheses and distribute, and then you get back to this again. But it's much easier just to go, okay, these 2 will be positive, and then these 2 will be negative. Make sure you have 4 terms. Okay, 14. So number 15. How many terms do you think we're going to have? We are going to have 1, 2, 3 terms. Well, it's hard to see that last one. 1, 2, how about this? It's a little bit better. We have 3 terms here, okay? And nothing's in the denominator, so this is all addition. So we will have log base 3 of 2 plus log base 3 of a plus log base 3 of b squared. That is your first step. 1, 2, 3 things. Split them all up. But this one does have an exponent, so it needs to go in the front. So the final answer is log base 3 of 2 plus log base 3 of a plus 2 log base 3 of b. And that is the final answer. All right, number 16. Okay, got to be careful that we have this fifth power on everything. Please remember the fifth root. Please remember that the fifth root of q is the same thing as q to the 1/5 power. Okay, now say if I had the fifth root of qp, that would be q to the 1/5 power, p to the 1/5 power. Okay, so that's what we're doing. Now here we have 1, 2, 3, 4 things. So when I'm all done, I'm going to have 4 terms. Okay, but first we have to do this. We have to do this. We have to take this fifth root and turn it into the 1/5 power on each of these 4 things. So this is what I'm going to have. Log. And look, so basically I've got 3 to the 1/5 power. Now x to the 4th, maybe I better do this off to the side. You see I've got x to the 4th that I'm about to do, and I'm about to do x to the 4th to the 1/5 power. Well, you multiply these, right? So this is like 4 over 1. So that's going to make x to the 4/5 power. Okay, so that's why I have 4/5 right there. And then I'm going to have y to the 1/5 power. Now here comes z. Now here again I've got z squared, and I'm about to do it to the 1/5 power. But again, this is like 2 over 1, so that makes z to the 2/5 power. So that's why I'm going to have z to the 2/5 power. Okay, so I've got all 4 of these things. So it's all multiplication. So I'm going to wind up with 4 terms all added together. So this will expand as log 3 to the 1/5 power plus log x to the 4/5 power plus log y to the 1/5 power plus log z to the 2/5 power. Notice none of these are bases. This is not log base 3 of 1/5. This is invisible base 10 everywhere. Anyway, the last step is exponents. In expanded form, all of these exponents should be put in the front. Okay, so that's why your final answer is going to be 1/5 log 3 plus 4/5 log x plus 1/5 log y plus 2/5 log z. And that, my friends, is the final answer. Alright, that's number 16. Alright, here comes number 17. Alright, this is just like one of them that we did. It's just like number 14. Remember when we saw 1, 2, 3, 4 things? Anything in the numerator came out positive. Anything in the denominator came out negative. That's what we're doing again. All right, so I'm seeing 1, 2, 3 things. 2 positive and 1 negative. So I will simply have the log of 2, that's positive, it came from the numerator, plus log x squared, that's positive, it came from the numerator, minus log 5, that's negative because it came from the denominator. That's what you do. Now, any exponents go to the front. There's only one exponent. This 2 is going to come to the front. So the final answer will be log 2 plus 2 log x minus log 5. Okay, now this one, again, that's square root, just like when I had the 1/5, the fifth root, and I had to do the 1/5 power on everything inside. The square root is like the 1/2 power. So this will be the same thing as having log base 5 of x to the 1/2 power, y to the 1/2 power, over w to the 4th power. Now once again, I need you to see I've got 1, 2, 3 things. The 2 things in the numerator are going to come out positive, though they will be positive terms. This 1 thing in the denominator will give us a negative term. Positive, positive, negative. So I will have log base 5 of x to the 1/2 power, positive, plus, plus log base 5 of y to the 1/2 power, all right, numerator, positive. This next one will be negative, so minus log base 5 of y to the 4th power. Now, since we have exponents, anything with an exponent is going to end up in the front. So the final answer is going to be 1/2 log base 5 of x plus 1/2 log base 5 of y minus 4 times the log base 5 of y. And that will be the final answer for number 18. All right, so looking at number 19, we have the log of 245. Somehow we've got to write this either using a 12 or an 8 or 7 or 5. All right, just keep that in your mind. 12, 8, 7, or 5. Stand by. So the first thing I try, I see this 245. I'm going to look at the chart, see if it's on there. Oh, boo, it's not on there. So I got to do something else. Well, okay. Look and see if one of these things will divide into 245. You know, 5 is one of the things we're shooting for. And 245 is definitely divisible by 5 because it ends in 5. So if I were you, I would do this. 245 divided by 5. Kabam. So you get 49. That means 245 is 5 times 49. Let's use that so far. Okay, so far we've got, this is like log 5 times 49. So we've got the 5, that's good. Now the 49. Oh look, the 7, hey, 7 is one of the things we were shooting for. And 49, right, 7 squared, feel me? So this will be log 5 times 7 squared. All right, because Haley and Kelsey, they basically told me how to do this problem because I had no idea, but they helped me out. Thanks, guys. You're the best.
You're welcome. You're welcome.
I appreciate that. So boom. So we've got 5 times 49, and that became 5 times 7 squared. Now it's time to split this up. Do not put this 2 in the front right now. You got to split it up first. So, we're using the product property. So this is going to split up into addition. So this is going to be like having log 5 plus log 7 squared. Okay? So that's going to be log 5 plus. Now this exponent gets to come in front. So that'll be 2 log 7. Now log 5 and log 7, those are facts that we have. So, okay. Log 5, that's 0.7. Okay, so this is 0.7 plus 2 times. And log 7, that was 0.8. So this is what we have. And we could put this in a bootleg calculator and figure it out. So we have 0.7 plus 1.6, and that is 2.3. So that's the final answer for number 19. All right, now number 20. This is division, so we can use the quotient property and turn this into a subtraction problem. So this would be like having log of 49 minus the log of 12. Now 12 is already good because that's one of the numbers that we're given. But 49, again, we can write 49 as 7 squared. And then we'll be good. So this will be log 7 squared minus log 12. And this 2 is going to come out in the front. So this will be 2 log 7 minus log 12. Okay, log 7 was 0.8. So this is 2 times 0.8. And then log 12 is 1.1. Okay, so this is 1.6 minus 1.1. So this is 0.5. So that is the final answer to number 20. All right, number 21. Well, 144, let's see, 144, I know that is 12 squared. And I like that because 12 is one of the facts that we're given, all right, log 12. And 125, I know that that is 5 to the third power. And again, 5 is one of the facts that we're given. So then we can just use the quotient rule and write this as log minus log. So this will become log 12 squared minus log 5 to the third power. Now these exponents are going to jump to the front. So this will be 2 log 12 minus 3 log 5. Okay, log 12 was 1.1. So this will be 2 times 1.1 minus 3 times, all right, and log 5 was 0.7. Okay, so guess what? This will be 2.2 minus 2.1. So if you subtract this, you're going to get 0.1. So that's the answer to number 21. All right, and then there's number 22. Now looking at the chart, I'm really hoping that 3,125 is on the chart. Go chart, go chart. There it is, 3,125. That is 5 to the 5th power. 5 to the 5th power. Okay, so that means what we have here is log 1 over 5 to the 5th power. So we can, I mean, there's more than one way to do this, but one way is to go ahead and use the quotient rule. Since we have a fraction, we can turn this into subtraction, this minus this. So this will be like having log 1 minus log 5 to the 5th power. Now this exponent is going to come to the front. So I will have log 1 minus 5 log 5. Alright, now log 1, this is not one of the facts we're given, but we don't need it. Okay? Because look, I'll just do this off to the side. Log 1, what's the invisible base right here? What's the invisible base?
10.
It's an invisible base of 10. Okay? Can you look at this and evaluate it? Like 10 to the what power will give you 1?
0, 1, 0.
0. Okay? Because anything to the 0 power, because you're asking yourself 10 to the what power will give you 1. Right? That's 0. So log 1 is just 0. So it's just 0 minus 5. And then again, log 5, let's see, what was that? Oh, that's 0.7. All right, so this is going to be negative 3.5. And that is the answer number 22. Oh, could it be? Is that the last problem? It's crazy. Yep, that was it. I will see you on the next video.